Hello guys, welcome back to Quadratic Functions. Here we just have a little summary of what we've done in the previous videos. So the first video, the very first, were dedicated to basic parabola. We explore how to plot it. So next step, we trying to apply like standard or general form, x squared plus bx plus c. That's the complete quadratic expression for the parabola with a, b, and c coefficients. And in the previous two videos, we discussed the vertical horizontal translation, so vertical translation by k units, and horizontal translation also by h units. And we also considered simply the vector of translations, right, that simply represent the combination of vertical and horizontal translation. So horizontal by h units and vertical by k units, and hence we arrive to the general form where we might have x plus minus h squared plus k. So in this case we consider h as positive, so and if we took the minus h, we transferred to the right. So if we take expression g from x, the function x minus h squared, we'll get the shift to the right, while if we take x plus h, we moved our parabola without changing shape to by h units to the left. Okay, here we considered on top of that graphs in general form, and we'll try to compare with what is known the vertex form of the parabola. But even before, we also explored scaling up, right? Just simply applying a coefficients. So right now, what I'm going to show you, I'm going to show you how the general form is connected with the vertex form. That can be written this way. So for simplicity, instead of x plus minus h, I will use the standard vertex form, because in standard vertex form we only use x minus h. However, h might be positive or h might be negative. Okay, so as well as for k might be positive or k might be negative. And that's for simplicity, we will use x minus h. So depending on h sign, if h is positive, so x minus h will simply determine that the parabola will be shifted h units to the right, okay? And if h is negative, we'll get simply like x minus, instead of h, we can put any negative number like minus 3, and we'll get x minus minus 3, so we'll get x plus 3. X plus 3 means that we transfer or translate horizontally by 3 units to the left, okay? That's what it means. So here we'll be using x minus h as general form. All right, so what I'm going to do, I'm going to show you how from basic parabola, by applying three transformation. First, we start from scaling up down, then we apply horizontal translation by h units, and then we apply vertical translation by k units to our basic parabola, which you can see here. That's the standard form for the basic parabola. So no coefficient, no leading coefficient, so it means it's a equals 1, so nothing changing with the shape, right, with the size of the parabola, and without like other terms. So that's the simplest form for the basic parabola. Okay, so and I'll show you how, by applying those 3 consecutive transformation, how we can arrive to this vertex form, what is known. So that's the vertex form. Okay, so let's start doing. And first we need to arrive to the vertex form, and after that we just compare how to get from the vertex form, how to get the general form, and how from the general form to get the vertex form. Okay, so let's start doing. First we apply scale up by coefficient a, so that means after the first transformation we've got y1, some new function, which is a times the previous one. Okay, simply it will work like your a times the right side of your simplest parabola times x squared. Okay, so what it means, we scale up or down depending on coefficients. Okay, and on some example, I will show you that for simplicity, let's take a equals, let's say 2. So all the values will be multiplied by 2. So in this case, when a equals 2, we simply get that y1 is 2x squared. So all values multiplied by the previous value, all values of the previous function were multiplied by 2. So in this case, if we apply this fx here, so as you remember for transformation theory, we'll get, so I'll use the blue color for that, when a is 2, we'll get simply 2 times the previous value of the basic parabola. In this case, it would take like level 1 for y. It's simply for x equals 1 and -1, it becomes 2. Remember, it gets narrow. For, let's say, 4, yes, for 4, we'll get 2 times more is going to be 8. So when x is 2, now we'll get 8 here. And that means we've got this form of the parabola. That's the first step. So that's the first step after scale up by a factor of 2. Okay, so next we apply horizontal translation by h units. Okay, so h might be positive and negative, but generally it looks like that on the previous step, y1 simply will take not from x, but from x minus h, okay? In this case, we'll simply get a times x minus h squared, okay? That's how we get. Let's say we transferred by 3 units to the right. If we transfer by 3 units to the right, it means that we'll get y, so this is y2 function from x, that is simply y1 from the new argument x minus h, because we translate by 3 units. So that's why our function y2 from x, or just simply y2, will be equal to 2 from the previous step. We take into account a equals 2. So 2 times x minus 3, which is squared. Okay, let's try to depict what actually happened. Now we track on the vertex for the blue parabola. It's still here in the origin. And now because we've got x minus 3, so new vertex, as you remember, when x minus 3 equals to 0, so that will happen when x vertex equals to 3, while y vertex stays the same, 0, right? Because no vertical transformation has been done, right? So that's why we have a shift by 3 units to the right. And that's how algebraic equation will look like after this horizontal transformation by h units was applied. Okay, let's shift our parabola, and in this case I will use red color. Oh no, red, we already used that. So let's take this one, okay, and we simply translate the vertex by 3 units here. So now the vertex stays here, and parabola will have the same points, and every single point will be shifted by 3 units. For example, when it was like, now we're shifting not red one, but actually the blue one, right? The first scaling up process. So we take that point and transfer also by 3 units. But it seems to me that you can imagine how to plot it quickly. You just know that here's, so from the main y-axis there was 1 here and 1 unit to the left. So again, now the vertex or the line of symmetry for new parabola that was transferred horizontally, oops, it's here, right? And that's why you can put the new vertex, sorry, new line of symmetry exactly as if it passed through x vertex equals 3. That's new line of symmetry. And symmetrically, you're trying to restore your shape. So you know that it was 1 unit here. So we'll get 1 unit here and here. So we restore the shape. And also, for example, for 8, there was 2 units. At the level of 8, we've got 2 units. So we'll have at 5, right, a new point. So that's why we just simply connect. That's how we can easily restore the shape without any calculation. You just simply keep track of relative distances to the new axis of symmetry. Okay, that's how you restore the shape. And this is going to be new function, which is y2 equals 2x minus 3 squared. Okay, next one. Let's apply vertical translation by k units. So what it means, we'll definitely get a new function y3 from x, which is from your previous one. What do you need to do? You just simply, to the previous step, need to add k units. If k is positive, we translate it as by that amount of units up, right? If k is negative, we translate it down. So in general form, we'll get a times x minus h squared and plus k. Simply what we'll get. So for our case, let's take for simplicity k equals, let's say, 1. We just simply transfer it by 1 unit up. And that means for all parameters, when a is to horizontal shift by 3 units to the right, and now new parameter, the vertical shift for parabola is k equals 1, we'll get our y3 function equals to, instead of a, we just simply use the previous expression for y2, which is here, right? And we simply put 2x minus 3 squared, and on top of that we add 1 unit. Okay, now let's see. So I use the black color now, and we restore the final shape for our parabola. We simply taken our green parabola and we add 1 unit to every single point. So we keep track of the vertex, and now vertex becomes here. So we simply shift every single point by 1 unit, right, up. And now we're smoothly connected. Okay, that was the first one. So I zoom in, and here we'll do the same. So we simply, now the vertex, let me just connect more smoothly. So we shift all the points by 1 unit, right, from the previous step. Okay, so vertex, now it's here, then this point will be shifted here, that point at 8 level for y we shift to the 9, right? And now we can smoothly connect with a smooth line. Okay, this black bold line stands for y3. Okay, and here we'll do the same. So we just simply do in a very symmetrical way. We just reflect this right branch along new axis of symmetry that goes through 3. Okay, so the vertex becomes, instead of 0, 0 that was originally, now just remember that's simply x minus 3. When x vertex equals 3, we'll get 0 in this bracket, so x vertex is 3, and this is y vertex, which is 1. So we can mark as 3 and 1. And indeed, if you have a look what you did visually, that's exactly right. 3 units here and 1 unit up. So I can use this purple color to show you that it was translated by 3 units here and 1 unit up. Okay, so plus 3 units here this way and plus 1 unit up. That's how it can be done visually. Okay, we've translated, we've got this form as the final function after all 3 transformations being applied in consecutive order, or just in, yes, so step by step. And that's how we get, so the black line, it stays for function y3, which is 2 times x minus 3 squared and plus 1. That's our final function. Alright, so guys, I promise you to explain how to convert from the general form into the vertex form and how to do it the way back. So here we'll apply that and I'll show you how to convert the general equation into the vertex form. So let's say general equation y from x is x squared plus bx and plus c, and our vertex form is simply a times x minus h squared plus k. All right, so first of all, I want to show you that this a coefficient is the same, right? Just remember what we did before we multiplied by a, right? This was scaling up, and this coefficient finally stays here. So a is not changing, so they are the same. But how to connect h and k with b and c, or probably with a as well? So that's the right time to show you. I'll show you from the vertex form back here, and then I'll show you the way back. So first of all, from the vertex back to the general form. Okay, so what we're gonna do from the vertex back to the general form, we simply need to expand. So you need to expand brackets. Okay, so simply expand the brackets. Let's do it, and we'll get y equals to, we'll get a, we use the formula, right? X squared minus 2hx and plus h squared. That's what we've got. Then we simply add k on top of that. What we can do, we can simplify and say that we have ax squared minus 8 times 2ha, right? Sorry, 8 times 2h and times x, and simply and finally 8 times h squared, and finally plus k. Okay, so now I just simply group. That's the first leading term. This is the second interim term or middle term. And finally, this expression is simply free coefficient because h, and k, they're numbers, right? Okay, so here we've got x squared, bx, and c. So we've got ax squared, let's just restore the same form, bx, and finally we've got c. And now what we're going to do, we just need to make a comparison term by term. So we've got this term, they are the same, and that's why, so actually this a is this a, obviously. However, for the second term, what we've got the following, right? We've got negative, I just highlight, negative 2ha is actually b, so we can write that b is simply negative 2ah, okay? From where, if you remember that h is the vertex coordinate, so x vertex is simply h, and if you express h from here, we can figure out that h is negative b over 2a, right? Because negative 2a is one, like one factor stays before h. In order to find h, you simply need to b divided by negative 2a. And hence, the x vertex of the parabola have the value negative b over 2a. Remember, before, you already know that. You already knew that, but you never been proof of that, right? Now you have an evidence how your h, simply x vertex coordinates, is connected with b and a coefficient. It's simply negative b over 2a. Okay, next up, we've got c coefficient, which is here, and that's completely what stays on the top, right? H squared plus k, that's for vertex form. Okay, so we can say that C, the last free coefficient, is simply h squared plus k. That's the connection. That's the connection. So that's why if you want to figure out like what stays for a, b, and c coefficient, if you have expression for the vertex form, you can simply say that just do by comparison. Okay, I'll show you quick how to do that. For example, let's say you have the general equation and you have the vertex form. Let's say the vertex form is 2 times x minus 3 squared minus 1. Okay, so what are you going to do in order, so your question, how to find coefficients. So how to find coefficient a, b, and c for the general form or for the standard form. So your goal, how to find coefficient a, b, and c for your given parabola. All right, so what are you going to do? You just need to expand the brackets, and let's do it quick. So we got x squared minus double x and times 3, so we got minus 6x, and finally we add 9, right? Minus 1. Then we simplify and we'll get 2x squared minus 12x, and 2 times 9 will get 18. So 18 minus 1 will get 17. All right, now you have an evidence that coefficient A is 2, coefficient B is negative 12, and coefficient C is 17. That's what exactly need to do. So from here we know that coefficient A is 2, B is negative 12, and C is 17. That's your general form. All right, so that's from the vertex back to the general form. How to restore back, how to get from the vertex form, from the general form, to the vertex form, All right, this might be a bit more tricky because there are actually several ways to do that. Okay, how would I do? I'll show you complete and square way, because sometimes you might be asked, like using complete and square, please guys explain how you can get from the general form and how you can get the vertex form from that. Okay, simply I'll try to show you. So y from x is x squared plus bx plus c. That what are you given initially? So you're given coefficient a, b, and c in your case, and you need to come back to the vertex form. Okay, because the vertex form use the complete and square, right? So your x variable is isolated from like other numbers and it's completely with square. So we need to reach this form. Okay, so how to do that? In general, I'll show you, but however, like general is only the proof. So consider this is sort of the proof and never like apply it when you're trying to solve like given example. Okay, I'll show you how to do it in a given example. But here is sort of proof. So what I'm going to do, I'm just simply want to factorize from that expression a, so that I'm left with x squared plus b over ax. And finally, I add c. Okay, so next up, what I'm going to do, I'm going to use the complete square formula. So I've got x squared, then normally I need to have 2x by some other number, which is considered later on squared. Okay, so right now what I've got, I consider the expression in the brackets only. So that's why I've got x squared, then I use the pattern 2x, but because I wrote 2x, but I have b over ax, of course I need to leave b over a, but immediately with 2. You know why? Because I need to come back to your original b over ax, from where I have 2x That's sort of artificially. And then I need to divide by 2 so that if I cancel 2 and 2, you see that I will left with x b over a. That's what I exactly have. But I need to in order to have the formula for complete square, because later on I'll write x plus something here. I just mark as the purple, so some purple square. Instead of purple square, there's some like expression, some number, and which is squared. Okay, so now I want to figure out what this square is. The square is the rest part, so I've got, I just erase this canceling because I need to have that. So according, just compare what I have. I need to have 2x, and what is the left part? This is exactly the square. This is exactly the square here, right? Just have a look one more time. X squared, okay, we have according to the formula. Then we need to have double product of your previous term, one term, x, and something that you later raise up power 2 according to the formula. So this purple square is exactly the rest part of your expression. So that's why you design this way. So b over 2a. And hence, finally, I'll add b over 2a, which is squared. Okay? Before, I didn't have that, so I immediately subtract this term. So instead of this purple square, we've got b over 2a. So that's why here I need to have to like finalize my formula. I need to have this square squared. Okay, purple square is squared. And that's why instead of purple square, I consider b over 2a, so I square it up. And I also immediately subtract this square so that I can, again, if I cancel, I will left with my original expression because I'm not supposed to change it at all. Okay, so I erase canceling because I'm not going to cancel. And that's what I left with. Okay, this part is the formula. So this part is simply x plus b over 2a, which is squared. Okay? So, but I need to add c later on. So that was expression times a. So I close the brackets. And now on the top of that, I add c. Okay? So that's why what I actually have, I have a times your formula, right? You apply the formula to your expression. So from here, you apply the formula and arrive to that. But, so that was only this part. What about minus b over 2a squared? I just simply times by a. So I'll get negative a times b over 2a squared. Because now I don't need this term like inside the brackets. I want to isolate to have a complete square. So this is complete square. While this left term, negative b over 2a squared, I don't want to keep inside, right? Otherwise the formula won't work. So that's why I I multiplied by a, and that's what I've got. And on top of that, I'll need to add c. Okay? Now, let's compare. So remember, in the vertex form, I need to have a times x minus h squared plus k. So let's write this part in here and just compare it with what I have. So I erase that for a while and I write that this my function y from x equals to. Okay, I have this form, but normally I should have something like a times x minus h squared and plus some k. All right, the same. Now compare the general vertex form. What are you supposed to have and what do you have right now from your general form? So what you can do, you can simply write that this expression in the brackets is exactly the same as here. So that's why negative h should be equal to b over 2a. So you can write that negative h is simply b over 2a, or from where h is simply negative b over 2a. Just remember, we've got this block from here. Of course, as you understand, from the vertex back to the general is much easier. But this is hard because we consider like general proof, and we have like lots of symbols and letters. So we've got that, and this is the vertex, x vertex. And now the rest coefficient k should correspond to the rest part of your equation. So here k is simply, we write the k is, I just rearrange and say that it's c minus, okay, a and 2a squared. So actually I can cancel, right? If I raise up power 2, b squared, and the bottom part will be 4a squared. So 1a will be cancelled. So I'll get 4 with a in the bottom part. And that's your k. That's your y vertex. Okay? That's the connection. Negative b squared over 4a and plus c, that's your k value. Okay, let's compare with what we have. We've got c, a, h squared plus k. But instead of h, if you put negative b over 2a, you'll simply get your c value, okay? You can practice by your own, guys. So if you plug instead of h here and raise power 2, you'll get exactly this value for k, okay?